Here's an example, something I'm hearing very often as a question. I have a warehouse or a library. How do I best do that? So for structure like this, characterized by corridors where people might be and columns of obstacles in between. These might be shelves with books, or there might be metal shelves. So these will be at least an obstacle to some degree. They might not be blocking everything, but some of it. And that means I typically have two options. Either I come from above, trying to, as if it was a shower, to supply the signal from above, or I can put access points into each of these lanes. Obviously, then I would need quite a few more. Being on either of the sides of the room, to the left or the right, would not contribute an awful lot, because then I would have to go through all of these obstacles. And then, of course, how many I can place depends a lot on my budget. For crowded places like university buildings, the longer we're doing this, we're getting to a sort of one access point per cell design, bringing down the output power of each access point quite a bit so they don't spread their signal all that wide, but many small access points concentrated for the different parts, the different cells of the building where users might be. That, of course, again, depends on the budget available. So, and as an alternative, if I don't have the budget or the will or the possibility to deploy access points in each and every one of these single cells, the rooms, sometimes coming from outside, can be an alternative. Like if you have a multi-story building, say with many offices or auditorium rooms, classrooms, sometimes if you can find a place outside opposite the building, that might offer an alternative. Keep in mind though, first verify if your windows are transparent. Windows can be metal coated, and then they might actually be an obstacle for the waves, canceling out a lot of your radio signal. So verify that first. But outside coverage can be an alternative to this many cells indoors approach. I talked earlier about the omnidirectional antenna and its donut pattern. Here's a little use case, and what we're showing is just we have an antenna tower to the left, we have a building in the middle, and then we have our users on the other side of that building. The first picture, top left, obviously not a very good idea because all of our radio signal goes into that building. It's blocked. The user will not be very happy. The first step to improve this is we can bring the antenna up high. That's good, but now remember it has that donut pattern. It's quite directional. If seen from the side, means our beam will actually miss the user on the right-hand side. So not a lot of improvement. Next thing we can do, we can use an omnidirectional antenna which offers tilting. You can get antennas that actually have this directional pattern, but they tilt it downwards like this. And then I can hit my user. So here for the first time I have a direct connection from where the antenna is to the user, so that's improvement. But half of my signal still goes to a place where I don't need it, out to the left where the users aren't at all. And the next improvement here would be choosing a sector antenna, a directional antenna that only puts the output power to where the users actually are. And this one I can tilt down to hit the potential user on the other side of that building. This as a little example how you can approach antenna placement and choice of antennas.